This time around we're going to write a balanced chemical equation starting from a description of the reaction, and we're going to follow some steps to do that. So let's see how it works. The very first thing we want to do is write the correct formulas for the reactants and the products. If we don't have correct formulas, we have no chance to balance an equation. So let's look at an example. The reaction of nitrogen together with hydrogen yields ammonia. It's a widely used reaction. Millions of pounds of ammonia are made every year. And to write down a chemical reaction or a balanced chemical equation for this reaction, we've got to get the correct formula for nitrogen. It's a diatomic molecule. For hydrogen, also a diatomic molecule. And for ammonia, which has the formula NH3, one nitrogen atom bonded to 3 hydrogens. So what do we do next? We're going to organize our formulas now. We want to put the formulas for the reactants on the left-hand side of our equation, the formulas for the products on the right. We're going to separate 2 reactants with a plus sign. If we had 2 products, we'd also separate them with a plus sign. And we're going to use our arrow, our chemical yield sign, to separate the reactants from the products. Let's see what that looks like here. So here's our skeleton equation down here. It's not a balanced equation yet, with the reactants nitrogen and hydrogen separated by a plus sign, the arrow between the reactants and the one product that we have in this case. Alright, so what are we going to do next? Next, we need to count up the number of atoms in each substance that's in the equation. So we're going to count each substance separately. So here's our skeleton equation. We're going to look at the formula for the first reactant, nitrogen, with the formula N2. That 2 means that there are 2 nitrogen atoms bonded together. So we're going to count them in this way, or we're going to write it down in this way. We're going to write 2 nitrogen atoms there. Okay? Same deal for hydrogen. H2 means that there are 2 hydrogen atoms bonded together in that molecule. And for this molecule here, we have more than one type of atom. We're going to put them all together. So this molecule has 1 nitrogen atom and 3 hydrogen atoms. And the circle that I draw around these means they're all together in the same molecule. The circle also reminds us that as long as we are working on this equation, we cannot change any of these formulas that we have. They're already the correct formulas. We can't change them just for the convenience of balancing the equation. So what that means is we can't go inside any of these circles and change the information that we put in there. Now we're going to get to the work of balancing. We're going to balance each type of atom separately, and to do that we're going to use coefficients. Let's see how it works. We can see that, here's the line that separates our products from our reactants, that on the reactant side of the equation we've got a total of 2 nitrogen atoms. On the product side we only have 1 nitrogen atom. That violates the law of conservation of matter, which says that all the atoms we start out with in a chemical reaction are still going to be there at the end. The way it's written down now, that's not happening. And the same thing is true for hydrogen. We have 2 hydrogens over on the reactant side of our equation and 3 hydrogens on the product side. So we don't have a balanced chemical equation. We're going to look at each type of atom separately. First, nitrogen. 2 nitrogens there, 1 there. What can we do to balance them? We cannot change anything that's inside the circle, but what we can do is use a coefficient to multiply the things that are in this circle. In other words, if we start off with 2 nitrogen atoms over here, maybe what's happening is we're making 2 ammonia molecules over there. So this 2 is a multiplier for everything that's inside the circle that it's in front of. Let's do the same thing with hydrogen now. As it stands, we have 2 times 3 or 6 hydrogen atoms showing on this side of the equation, only 2 over there. What can we do about that? We can add a coefficient in front of this circle here that multiplies everything that's in the circle. We've looked at each atom now. We've balanced each atom. Let's see what our next step in our process is going to be. we're going to go back and we're going to check each type of atom. In this case, that's not a big deal, but sometimes as we're going through all the atoms in a chemical reaction, all the types of atoms, we change things that we had right previously. So we need to check. And then we're going to reduce our coefficients. Let's see how that works. We've got our count with our coefficients. Over on this side of the equation, there are 2 nitrogens. There are 2 times 1 or 2 nitrogens over there. There are 3 times 2 equals 6 hydrogens on this side of the arrow. 2 times 3 also equals 6 hydrogens on this side of the arrow. Now we have a coefficient in front of each circle, a 2, a 3, and a 1. Even though it's not written down, there is an implied 1 here. Can we reduce those to a lower whole number ratio? We can't. So those are going to be our coefficients. And the last step in our process is going to be to move those coefficients into our equation so that we have a correctly written balanced chemical equation. And here we see that done here. 1 molecule of nitrogen reacts with 3 molecules of hydrogen to yield 2 molecules of ammonia. So there are some steps for writing a balanced chemical equation.